This video is about asymptote. An asymptote is a line that the graph of a function approaches but never touches. It can be vertical, horizontal, or slant. This is an example of a vertical asymptote. This is the function f of x equals x plus 3 over x plus 1. The green one, that's the function. And its vertical asymptote is the line x equals -1. This is also an example of a horizontal asymptote. This is the function f of x equals x plus 3 over x plus 1, and the line y equals 1, that is its horizontal asymptote. This is also an example of a slant asymptote. Okay, the line y equals 3x plus 1 is a slant asymptote. But how to solve the vertical, horizontal, or slant asymptote? Start with vertical asymptote. Vertical asymptote is a vertical line which corresponds to the zeros of the denominator of a rational function. It describes the behavior of a graph as the output gets very large or very small, meaning the y values gets very large or very small. To find the vertical asymptote of a rational function, simply set the denominator equal to 0 and solve for x. Example, f of x equals x plus 3 over x plus 1. Look at the denominator. Okay, equate the denominator with 0. So x plus 1 equals 0. And x is equal to -1. So x equals -1, that's the vertical asymptote of this function. Okay, to show you the graph, okay, this is the graph of the function f of x equals x plus 3 over x plus 1, and this is its vertical asymptote, the line x equals -1. Next is the horizontal asymptote. The horizontal asymptote describes the behavior of a graph as the input gets very large or very small. So this input is the x values. While the graph of a rational function will never cross a vertical asymptote, the graph may or may not cross a horizontal asymptote. There are 3 cases when checking for the horizontal asymptote. So, we have case 1. If the degree of the denominator is greater than the degree of the numerator, there is a horizontal asymptote at y equals 0. Example, f of x equals 4x plus 2 over x squared plus 4x minus 5. Okay, look at the numerator. The degree of the numerator is 1. And the denominator, the degree is 2. Now, the degree of the denominator is greater than the degree of the numerator. So, this function has a horizontal asymptote at y equals 0. Okay, so this is the graph of the function f of x equals 4x plus 2 all over x squared plus 4x minus 5. And the line y equals 0, that is its horizontal asymptote. Next is case 2. If the degree of the denominator is equal to the degree of the numerator, there is the horizontal asymptote at y equals a sub n over b sub n, where a sub n plus b sub n are the leading coefficient of p of x and q of x for f of x equals p of x over q of x, and q of x is not equal to 0. So here, p of x is the numerator and q of x is the denominator. So we have a sub n as the leading coefficient of the numerator and b sub n as the leading coefficient of the denominator. Okay, we have this example. F of x equals 3x squared plus 2 over x squared plus 4x minus 5. Now, this function has a horizontal asymptote at y equals a sub n over b sub n. Now, look at the leading term of the numerator. The leading term is 3x squared and it has a coefficient of 3. So, the leading coefficient of the numerator is 3. Now, we are going to substitute a sub n by 3. Okay, so we have this one. Now, look at the denominator. The leading term of the denominator is x squared and its coefficient is 1. So, we substitute b sub n by 1. So, we have y equals 3 over 1 or y equals 3. So, the horizontal asymptote is at y equals 3. So, this is the graph of the function 3x squared plus 2 over x squared plus 4x minus 5. And this line, y equals 3, is the horizontal asymptote of the function. Now, the last case is this one, case 3. If the degree of the denominator is less than the degree of the numerator by 1, we get a slant asymptote. Example, f of x equals 3x squared minus 2x plus 1 over x minus 1. Okay, look at the numerator. The degree of the numerator is 2 and the degree of the denominator is 1. So, the degree of the denominator is less than the degree of the numerator by 1. So, the asymptote here is a slant asymptote. Now, to solve for the slant asymptote, divide 3x squared minus 2x plus 1 by x minus 1. So, you are going to divide the numerator by its denominator. So, you can use either long division or synthetic division. Okay. So I did not include here the long division and the synthetic division. So if you are going to divide 3x squared minus 2x plus 1 by x minus 1, the answer is 3x plus 1 and the remainder is 2. Now 3x plus 1, that is the slant asymptote. Okay, the quotient is the slant asymptote. So this is the graph of the function 3x squared minus 2x plus 1 all over x minus 1. And this line, y equals 3x plus 1, is its asymptote. And it is a slant asymptote. Okay, so to have a recap, asymptote can be vertical and horizontal. So again, vertical asymptote describes the graph or describes the behavior of the graph as its output, as the output gets very large or very small. While the horizontal asymptote describes the behavior of the graph as the input gets very large or very small. Now, a horizontal asymptote is at y equals 0 if the degree of the denominator is greater than the degree of the numerator. And The horizontal asymptote is at y equals a sub n over b sub n if the degree of the denominator is equal to the degree of the numerator, where a sub n and b sub n are the leading coefficients of the numerator and denominator respectively. Okay, a horizontal asymptote is a slant asymptote if the degree of the denominator is less than the degree of the numerator by 1.